Welcome to Unit 5, Lesson 7, Interpreting and Using Exponential Functions. Let's explore the ages of ancient things. Okay, halving and doubling. So this is going to be our rate. Remember, in an exponential equation, we always start off y equals a, which is our start, b, which is our rate to the x power. B is either going to be half or it's going to be double. That's what halving and doubling means. It means that your rate is half or double. Okay, a colony of microbes is growing exponentially and doubles in population every 6 hours. Explain why we could say this population grows by a factor of the sixth root of 2 every hour. Okay, so let's go back to exponential laws. The sixth root of 2 is equal to 2 to the 1/6. So 2 to the 1/6, let's write this bigger. 2 to the 1/6. This is 1 hour. And this is 6 hours. So it would take 6 full hours to actually double. So remember, 2 to the 1/6, if you raise it to the 6th power, or do 6 of them, you get 2 to the 6 over 6, which equals 2 to the 1, which is just 2. So this is why it goes by a factor. So 1 hour out of 6 hours. Remember, in radical form, the exponent is your denominator, the unwritten exponent, the index of the radical, which is out here. The 6 is your denominator. The unwritten exponent, which is a 1, is your numerator. So when you convert a radical to a exponential form, where you have a base and an exponent, or a power, where you have a base and an exponent, the numerator is your exponent. The denominator is the index of the radical. That's the number outside of the radical. A bacterial population decreases exponentially by a factor of 1/2 every 4 hours. So time. 1/2 is our rate. A factor of 1/2 is our rate. So if 1/2 is to the 4th power, every 4 hours. If every 4 hours is 1 unit, 1 whole unit, so 4 hours equals 1/2 decay rate. That means that the decay rate to the 1/4 equals 1 out of 4 hours. That's just what it means. So 1/2 to the 1/4 is the same as the 4th root of 1/2. Just using exponent laws. Carbon-14 is used to find the age of certain artifacts and fossil. It also has a half-life of 5,730 years. So if we was to write this, our half-life every 5,730 years. So that's how much it takes for 1 full half-life. Now, if we were converting this to 1 full half-life, then we have to make a division out of it, and we'll see that on the next slide. At a certain point in time, a fossil had 3 picograms, a trillionth of a gram of carbon-14. Complete the table. Okay, so we know that it takes 5,730 years for a half-life. So 3 times 1/2 to the 5730 over 5730 is equal to 3 times 1/2, which gives us 1.5. Now, 3 times 1/2 to the 1910 out of 5730 gives us what? We can just write this as 3 times 1/2. And 1910 divided by 5730 happens to be 1/3. We can write it like that, which is a very exact number, or we can approximate. But when nobody tells you what to round to, please round to 4 digits. Now, when we round, we look at the fourth number. We look at the number to the right. The number to the right happens to be a 0, so the 1 stays the same. So you have to remember your rounding rules for this one. And now for this one, we're given 0.75. So how do I figure this one out? Well, what's the relationship from 1.5 to 0.75? So if I take 0.75 and divide it by 1.5, that gives me 1/2. So that means another half-life has gone by. So what I'm going to have to do, I know a half-life is 5,730 years. So I'm going to add 5730 and 5730, and that's going to give me 11,460. So that's how many years it takes to get 2 half-lives done. Okay, a scientist uses the expression 2.5 times 1/2 to the t over 5730 to model the number of picograms remaining in a different fossil. So what is the 2.5? The 2.5 is the original number amounts of carbon-14 is known as C14. Okay. 1/2 is the decay rate. So that's your decay. Because it's less than 1, it decays. And 5,730 is your time of half-life. So that represents a time. So time always goes in your exponent on these types of problems. Would more or less than 0.1 picogram of carbon-14 remain in this fossil today? So 20,000 BC is 20,000 before Christ. We're in 2026. So 22,026. So let's calculate. 2.5 to the 1/2 to the 22,026 over 5730. And what do we get? This equals 0.1740952, blah, blah, blah. So now, when nobody tells you, we're going to round to 4 decimal places. So the zeros in the 4th decimal place, I had to look at the number to the right of it. The number to the right of it is 5 or higher. So that means our number is 1741. And no, more than 1 picogram would remain. So this is more. 0.17 is more than 0.10. And if we don't remember our numbers, to compare numbers, 0.1, all you got to do is add zeros. And how much would you rather have, 1741 or 1,000 if it was in dollars? You would rather have a bigger number. Okay, let's look at the next problem, 7.3, and all the rest of the pages go with this. The half-life of carbon is about 5730 years. So that means our rate is 1/2, and we're at the time over 5730. No matter what the question asks, this is our rate, this is our exponent. Pythagoras lived between 600 and 500 BCE. So let's take the middle number, which is 550 BCE or BC. Explain why the age of a papyrus from the time of Pythagoras is about half of a carbon-14 half-life. So let's see. 2026 plus 550 or 2026 minus a negative 550, which is the same as 2026 plus 550, gives us 2576. So 2576 divided by 5730, because that would be our exponent, is 4496, which is about 45%. It's about 45%, which is very close to 50%. So Pythagoras would have been around at that time if we found one and carbon dated it. Now, someone claims they have a papyrus scroll written by papyrus. Testing shows the scroll has 85% of the carbon remaining. This scroll is a fake because it's too new. 85% is nowhere close to 45%. So this is why it's a fake. Okay, now if we were to come back and do this mathematically, if half the time expired, we would raise our amount 1/2, which is our rate, to the 1/2 power, because we said Pythagoras is about a half of a carbon half-life. So a half of a half gives us 0.7071 and a bunch of numbers. So we're just going to say 0.71, which is about 71%. So if this papyrus was around when Pythagoras was alive, only 71% of the original amount will remain. Since 85% remains, is too high. So that means the papyrus is much younger than 71%. And in a couple of days, in a couple of lessons, we will learn how to exactly pinpoint the age by doing another operation.